So the problem is a reverse integer. So you will be given a 32-bit integer. So you need to reverse it. So for example, if it is 1 to 3, you need to put 3 to 1. If it is minus 1 to 3, you need to put minus as it is and reverse the remaining part of your value. And if it is if they are trailing 0, then you're not supposed to return the trailing 0. Of course, if you're returning integer, the trailing 0 will not be part of that. So to solve this problem, first we will try to solve it very uh, by just manipulating the bits, and then we will see the condition, because there are two conditions. You need to also check whether reversing the value causes any kind of overflow or underflow. In that particular case, you need to return 0, and of course you are not supposed to use 64-bit integers while writing your algorithm. So uh, how to solve this problem? So you need to uh, uh, declare a variable called result, which will basically contains the return value. And then what you need to do, you basically create an integer by first taking the last digit of your input value, and then you need to multiply it by 10, and then add the second last, then multiply it by 10 again, and then third last, and so on. So uh, the algorithm should be look like, while x is not equals to 0, you need to update the result with result multiplied by 10 and x mod 10, and then x will be x equals less than 10, and finally you will going to return the result. So if you see what we are trying to do here, we take 1 2 3 as an input. Initially result will be 0. Then what we are doing, we are calculating the x modulo 10, so it will return the last digit. So your result will be updated to 3 in the first iteration. In the second iteration, we are multiplying 3 by 10 and adding the second last. So to get the second last, what we are also doing here is we are updating x with x divided by 10. So that means x will be at this point 12. So then we will iterate again, so we will get next time 2. So we will going to add 2 here, which will be 32, and then in the third iteration we will do 32 multiplied by 10, and of course here we will also update x with x by 10, so x will be 1 after that, and then we will do this equals to 1, and here x, when we do x 1 by 10, so it will be 0, and finally your result will be 3 to 1. So this will be, this is how we wrote this particular algorithm. But here we are not doing this thing right now, so we are not checking any underflow or overflow. That we will do a bit later. So first, let's try to run this particular piece of code and try to see whether it handle few cases. So here you see 1 to 3 is returning 3 to 1, and it is accepted, so that's good. So when we try to submit this thing, it will going to fail with a couple of scenarios where there is an underflow, overflow kind of thing. So you can see here it is giving a runtime error called signed integer overflow. So then before, so to address this particular thing, only thing we need to do before doing this operation, we need to see whether doing this operation will going to overflow or underflow. So first we will check for the overflow. Overflow only happens when x will be greater than 0. So in that case, what we will do, we will see if result is greater than int max minus x modulo 10 divided by 10. So basically we are just checking this guy. So if I just take this piece, so I'm checking this is greater than x. I cannot directly use this expression as it is, because if it is overflow, then of course it will give you an error. So I need to check whether the result will be overflow. So I'm just manipulating this thing here. So what I did, basically I just took this guy here, and it is simple mathematics, right? Say this, and then I'll just take it like this. I'll just take this 10 here, remove it from here, and put it here. So I just rewrite the expression slightly differently so that I can easily check whether the operation will overflow. So in this particular case, if it overflows, then I'll go to return 0, and then there will be the second case for the underflow. Underflow only happens when x is negative. In this case, same thing, I need to check result is less than int minimum minus x percentage 10 divided by 10. And here also I need to return 0. So again the same thing. So I need to take this here. This should be less than int minimum. So I just take this thing here, put it here, and then I'll take this 10 here like this. So this is the expression that I need to check. So now these are the two conditions that will make sure that your result neither overflow or underflow, nor underflow. And if it passes these two things, then only it will going to update the results. So now if you run this particular piece of code on a very simple test case, it still passes, and then I run it all the test cases, and in this particular case you can see now it is passing all the scenarios and the algorithm is correct. So this is how we can solve this particular problem without using any 64-bit variables. Another simple scenario when you do not have this particular restriction, where you can use 64-bit values, 64-bit variables. So in that particular case, this is a bit easy. You do not need to do these complex calculations here. So when there is no such constraint that you cannot use 64-bit integer variable. So in that particular case, you can declare the result as a long. You do your calculation, and then you check the result. If result is exceeding int max, or the result is less than int min, in this case you can say, okay, I'm going to return 0. So here, but we are using 64-bit integer. We are ignoring this problem still. But if there is no such constraint, then the algorithm is a bit simpler to write. So in that particular case, if we just run this particular test case, you will see it is still passing. So this is how you can do the problem in a slightly different way. Okay, thanks.